अच्छे तरीके से कर लिया है सबने? Okay. So today we are going to start the step number 2 of the same compound. Whose first step we have done last week. That is, you have done the preliminary examination, as I have just explained you before many times, that every compound will be identified by 4 steps. That is preliminary examination. Number 2 is your detection of elements, which is this one, which is today's work. And then third step is classification, and fourth is melting and boiling point. It depends upon the nature of your or state of the compound. So today you are going to write on the heading, that is, you have to follow the same format. I'm making it clear. Experiment number 1, step number 2, right? And what would be that? Detection of elements. The same heading you are going to write down here. Detection of elements. Either you can write, or you can write detection of nitrogen, sulfur, and halogens, right? Whatever is there. Now, what happens? They have given us a little knowledge of what is going to be happening here. You are not going to write this introduction here. You are simply going to write the object, and then you are going to write down the glassware you are going to use, and then you are going to write down the preparation of some extract we are going to prepare today. Now, what is this extract? It is called sodium extract or Lessing's filtrate, right? Or a sodium fusion. It's a sodium fusion test. Now, what does that mean? That sodium has to do something with this test. So, what is that? Sodium is a metal, you know, right? It's a very explosive metal, right? So, what happens that it reacts it will be fused with your organic compound, and resulting into what happens? It's in the ionic state. It's in the covalent state. They are, normally compounds in the organic world are joined together in a covalent state, so they are not detectable. So now, how to detect them? How to detect the elements present in your present organic compound? So this is one of the way to find out or to detect these elements, that is besides carbon and hydrogen, because we know that any organic compound, it's loaded with carbons, it's loaded with hydrogens, right? But what about the other elements that are there? So for them to be detected, they are not detectable because they are just joined to each other by covalent bonds. So that's why they are not detectable. So we need to convert them into their ionic forms. And for that, we need to prepare this sodium extract. We have to fuse our organic compound with this sodium metal. And what would happen? That sodium, when it reacts with this compound, what it's going to do, that you will be extracted in the water after. And what happens? There's going to be a reaction, that is sodium plus, when it reacts with your distilled water, it's going to make sodium hydroxide plus H2 gas. What happens? That it's going to make sodium hydroxide, which is an alkali. So it's going to make your solution a little bit alkaline. Your solution would be alkaline, though it wasn't alkaline before. It was a little basic. So it made it alkaline when you react this, because you fused the whole sodium, but the free sodium is still there. So what does that free sodium do? The free sodium, it reacts with the water, that is the distilled water, and it makes sodium hydroxide. And you get an alkali. Sodium hydroxide is an alkali, and in that sense, your sodium extract would be alkaline in nature. Now, these things can be asked from you in your Viva, whether online, whether physical, whether face-to-face, whatsoever. These things can be asked. So keep that thing in your mind, whatsoever I'm telling you. Now here there is a procedure, that is preparation of Lessing's filtrate. So you are going to write down the heading, preparation of Lessing's filtrate or sodium extract, right? Now keep that thing in your mind, that this procedure is given and it's written here. You have to write it down on your journal as it is. Don't use your own English, okay? Your super English, do not use it. Use this super English that is here. So just write down this English and write down this method only. Don't write the introduction. Whatever I'm telling you, I'm not going to repeat again. Listen to me for once, okay? You are very good and very nice students. And I'm very happy that you've been doing things very nicely. So now they have given us a little bit precautions here. So let's read the precautions first. Sodium metal is highly reactive. Do not touch it with water, right? It causes explosion. Sodium metal reacts even with the moisture present in the atmosphere. What does that mean? It means that it's hygroscopic, it reacts. So whenever you are speaking, even when we are speaking, even the molecules are spraying from our mouth, which are not visible to our naked eye. So if you are holding a sodium metal in your hand, it can catch fire, right? So be careful when you are dealing with the sodium metal. Do not touch it. You'll have a severe burn if you just touch it, and you'll Mr. Irfan is here. He's our lab assistant. He's gonna cut down the bigger piece of sodium metal into a smaller one, and which can be introduced into the ignition tube. Now let's read the procedure. Dry a small piece of sodium metal between the folds of the filter paper. That means a filter paper is required. And this is the sodium metal. So now dry, what do you mean by dry? That means it is immersed in some sort of a liquid. So basically what happens is sodium metal is never exposed in the air. It is supposed to be immersed in some sort of a solvent. So which solvent? Either kerosene oil, or if kerosene oil is not there, then what's the next substitute? Concentrated sulfuric acid. It is always dipped inside these two solvents, right? An acid or kerosene oil. Only these two things. So nowadays it's been immersed inside the kerosene oil. So when it's in the kerosene oil, you are going to cut down a little piece, and you are going to dry it between the folds of the two. Just take two filter papers and dry in between the folds of the filter paper, right? So this is what they mean. Dry the piece of a sodium metal between the folds of the filter paper. Introduce this sodium metal into an ignition tube. Now this is an ignition tube. So now you have this metal, you're going to introduce it, and it should go just lower down, and it should touch the bottom. It should be of this much size that it should go inside that ignition tube, right? And keep that thing in your mind that it is silverish in color. So just select and cut down the portion that is silverish in color, and it should be not more than the size of a pea. मटर के दाने से बड़ा नहीं होना चाहिए, right? Pea हमेशा बोला जाता है. It's just like that. So okay, now add the organic compound in such a way that it covers the sodium piece. Now if this is the sodium metal, if this is the ignition tube, now you have added the sodium metal into it. Now you are going to, with the help of a spatula, your organic compound. Which organic compound? Benzoic acid. Acha. The same organic compound, and you are doing the step number 2. So, and make the structure on the beginning. So you should be having this thing in your mind, that we are continuing with the same compound. This is only the second step, right? Yes, ma'am. So we know that this is benzoic acid. Now we are going to introduce few granules on this sodium, right? This is what they have written here. Add the organic compound in such a way that it covers sodium piece. Only add that much amount that it should cover the sodium metal. That is this much amount. Only this much amount should be added. That it should cover sodium metal. It should be of this much size. Now what you are going to do? Okay. Heat gently the lower end of the ignition tube. Now if this is you can say the ignition tube, and if this is your fire, right? Your flame. Heat gently. This is called gentle heating. You will keep it over, and you will keep it away for a while. Keep it over, away. What happens that the sodium will melt, and it will be like a shiny globule, like a mercuric bulb. If you have seen in a thermometer, you have seen a mercuric bulb, it would be like that. So when it is like that, what you are going to do? Heat gently the lower end of the ignition tube till sodium melts and react with the substance. And now what happens? The substance. What do you mean by substance? Your organic compound. Your benzoic acid, our organic compound. So it's gonna react with you, because it's not alone. It's with your organic compound. So it's gonna react with it, right? This is gonna happen. Now we are going to do a strong heating. They said that add a little bit. You can take few more granules and put over it, because it's a qualitative analysis, as I mentioned again. You do not need to measure. It's just, and then now you will do the strong heating. Strong heating, this is called strong heating. This is ignition tube, this is the flame. So the strong heating means like this. Don't tilt your ignition tube like this or this, because sometimes there is an unreacted sodium and it bumps out. It bumps out and it can damage the person who is standing next to you, or left or right side. So keep the direction of the ignition tube above it. Now keep the thing in your mind that your flame should cover. You have to heat strongly. What is strong heating? If this is flame, now see how it is covering the ignition tube. It should cover this much. This much level of your ignition tube should be covered with flames. Now these are all flames. What are these? ठीक है, समझ में आ रहा है कैसा, कितना आपने इतना ऊंचा फ्लेम इसको करना है, this much high, so that this much portion of your ignition tube should be burnt, right? And now keep that in your mind, the burners are not working properly. What they do, yesterday what happened, that there was a lot, the burners were giving red fire. So just move the lower portion of the burner and rotate a little bit, and you will have a blue portion of the fire. So just use the blue flame, don't use red flame. The red flame causes the ignition tube to be black. It will become black because of the carbons, lot of carbons, and your sodium extract would be colored, and we don't want colored sodium extract. Keep that in your mind. No colored sodium extract. Sodium extract should be colorless, and if you are having a colored compound, just throw it away and again make it. Again, go through all the steps, and keep that in your mind that sodium extract is always colorless. Okay, now what happens that you are going to, when it is red hot, at that moment when it becomes red hot, you have a china dish at one side containing 20 ml of distilled water, because now the extraction process starts, the second portion. Now you are going to drop your red hot ignition tube into the, if this is ignition tube, like this, that's it, right? And with the help of glass rod, not spatula, glass rod, you're going to crush it down like this. You will crush it, hold it and crush the your burnt ignition tube into small pieces, right? And now keep the ignition tube over the flame and reduce it to its half volume. It was 20 ml, so reduce it to 10 ml, so that you can perform the 3 tests, that is test for nitrogen, test for sulfur, and test for halogens, that are on the next page, on page number 23. You can see the 3 tests, that is test for nitrogen, first test for... Now the question arises, our compound is benzoic acid, right? So why we are going through all these tests? We know the structure of the compound. We know that it doesn't contain nitrogen, it doesn't contain sulfur, it doesn't contain halogens. So why we are doing it? For your practice. It's a known compound. You know the nature of the compound, you know the structure of the compound, you know the formula of the compound. So in that sense, you are going to match your findings with the findings given here, and you will come to know that no, it's not, nitrogen is not there. We have confirmed through the test. And what this test is, ferrous sulfate test, right? You will perform these 3 tests after that. Prepare sodium extract, and then we will do these 3 tests. On the next page, you are going to make 3 columns, just as you have done before: experiment, observation, and inference. And you are going to write down first test, that is test for nitrogen. What is that? That is ferrous sulfate test. Now what you are going to do, you are going to use 1 ml of your sodium extract, and you are going to react with ferrous sulfate, and followed by a few drops of sulfuric acid. And you are going to get a Prussian blue coloration. Now what is Prussian blue coloration? Could be this one, if the presence of nitrogen. If nitrogen is there, or there are different shades of blue. This blue could be Prussian blue, right? This is also Prussian blue. This shade is purplish. Now this is also Prussian blue. Sometimes your compound, if it contains nitrogen, this is also Prussian blue. This is also Prussian blue. So this is also Prussian blue. Sometimes if there are more, bulkier nitrogenous groups, so it becomes more darker in shade. So there are different shades. But in our case right now, क्या होना चाहिए? What would be the result of test for nitrogen? You tell me. What should be the result of our compounds today?
Colorless.
Why? Why colorless?
क्योंकि सोडियम जो है वो भी हमें कलरलेस चाहिए ना.
I'm referring to test for nitrogen. What would be the result of test for nitrogen? In our case, when we are dealing with benzoic acid.
And because nitrogen is not present in our compound.
Yes. So simple, beta, nitrogen is not there, so you are not going to get the result Prussian blue coloration. So you will simply write in the observation section, no Prussian blue coloration observed, right? Blue color observed. So nitrogen is absent. In the same sense, you are going to do the sulfur test for sulfur and test for halogens. But here our indications are given for test for sulfur and nitrogen present together. In the test number 3, when you are going for the halogen test for halogens, they have already said that if your compound contains nitrogen and sulfur, then perform this. So read the cautions that are given here. Read these hints, okay, before jumping to any test, always read that whether you are supposed to do it or not. So in our case, both the tests are negative, so we are not going to do the third test, right? And keep that thing in your mind. Test for sulfur. There are two tests. Number one, first one, and then lead acetate test. So lead acetate test is the confirmatory test. If the first test is positive, then you are going to do the second test. Otherwise, you will simply leave it because your compound doesn't contain sulfur. Right? So in that sense, you are going to do the three tests by first of all, initially preparing sodium extract, which is called Lessinger's filtrate. Lessinger was the scientist who developed this test, who developed this method to convert covalent compounds into their ionic form so that they can be detectable, right? And then you are going to perform these three tests. That is test for nitrogen, sulfur, and halogens. Now, your turn. If you want to ask anything, you can ask, and you just start your work. Yes.
And then first we have to make the sodium metal and then
Sodium extract.
And with the benzoic acid.
Yes.
Right. And then we are testing that benzoic acid and sodium for this all.
Better then you will be having a sodium extract. You will be having a solution that is called sodium extract, right? So you are going to take every time for every test you are going to take 1 ml in a test tube, and you are going to move according to this test. Add ferrous sulfate. Then again, for the next test, you are going to discard the first one, wash your test tube, and again take 1 ml of your sodium extract, perform the second test. Then again wash your test tube, perform the third test. By taking, so that's why I said that reduce here, they have written the. So right now I am checking the journal because my students have done this work last week and they have not get their journals checked, so some of the journals were left. So see, the date is missing, so students should write down the date of the performance should be there. So this is the journal how they have done it. So this is the checking time. My students are working, you can see them, they are working over here, right? The girls are over there. So I have given them the demonstration, and now they are doing the second part of the same compound, that is benzoic acid, but the second step, that is detection of elements. The students are reducing the sodium extract to its half volume, and then they will proceed on with the next reactions, that is test for sulfur, nitrogen, and halogens. Now they are writing it down, their observations on the journal. So this is how students are supposed to work accordingly, that they have to record all their findings on the journal as they are doing it. With their schemes, they are all disciplined, well, they are all in uniform, wearing aprons, they are following the rules of the lab. So this is, I think, the best group of this class. The, a little garden like in front of my organic chemistry lab. There are green trees all over. This is beautiful. In summers, these are all, they give a lot of shadow and provide a nice atmosphere. You can see here. These trees are very old. And that's just in front of my lab. So this is where I'm standing right now, and this is my lab here where my students are working, and I'm monitoring them how they are working. So here they are. So my students, hello and welcome with another video. So my students today have done the second part of the experiment, that is detection of elements, and I have demonstrated them nicely, and now they are doing their work. You can see them working from here. I can show you how they are working as they have been guided. I'm monitoring them because they are new students, they are not that much familiar with the steps, so I'm trying to be with them as much as possible. You can see them working. All are working, and all are, almost they have prepared the sodium extract. Now they are going to do the test for the element detection, the elements that are present with it. So I'm happy that my students have done their work nicely, and this group today's group is I think one of the most disciplined and most fast in doing in getting their results, and they are writing down all the
data in what they have seen up till now and what they have performed in the journal. So I'm happy that they are doing it. So hope, and let's meet again with something new, something more interesting and exciting, with some new updates. I'm Professor Dr. Mughal from Dr.MA Kazi, Dr.MA Kazi, Institute of Chemistry, University of St. Jamshara.